Hello and welcome back. Today we're going to be talking about correlations in psychology, the second type of research that we see psychologists conduct. By the end of the video today, you should be able to recognize the direction and strength of correlational graphs and what they can tell us. So let's go ahead and take a look. What is a correlational study? A correlation is the study of two factors and how they work together to see if one predicts the other. In order to understand this, I'm going to show you three different graphs that represent three different types of correlation. So the first one that we see here, you see on the top, it tells us it is the relationship between SAT and IQ. Now looking at this graph, you'll see that generally speaking, as our SAT scores increase, so do IQ scores. So as one increases, the other increases, and so this is known as a positive correlation. If we look at the next graph, we'll see here that there's a relationship between TV watching and GPA. As the number of hours of TV increases, we see that GPA here decreases. So as one is going up, the other is going down. And this is referred to as a negative correlation. The interesting thing here with TV watching and GPA is that some people might draw a conclusion from this, that watching TV makes your GPA go down. But we don't actually know if that's true. What if having a lower GPA causes people to watch more TV? We don't know, and therefore we cannot conclude that there is a cause and effect relationship going on here. We can only see a predictive relationship. If I know how much TV you watch, I might be able to predict what your GPA is. I might be correct, I might not, but it has some predictive value. Our final graph we see here is the relationship between sleep and IQ. And you can see that the scatter plot is all over the place. We don't have a relationship between sleep and IQ here. And so this is no correlation. These are the three types of correlations that we will see in psychology. What do these graphs and what do these correlations tell us? These tell us relationships. Correlations are a statistic that measure the degree to which two variables are related. We say it's a statistic because if you see on the top of each correlational graph, you'll see that there is a number there, a number between positive and -1. That is going to tell us how strongly related those two items are. Correlations do not imply causation, but they do have predictive value. And that's an important piece to remember when it comes to correlational studies. So as we look at these three correlational graphs, we can see three different types of relationships: positive, negative, or zero. You will want to be able to look at a correlation graph and be able to describe what type of correlation do we see. Is it positive? Is it negative? Or does it appear that there is no correlation or no relationship existing? The other thing you'll want to be able to say is how strong that relationship is. So again, on top of each graph, you will see a number. R is the letter that we use for correlations because R stands for relationships. The number will then be somewhere between -1 and +1. Whether it is negative or positive just tells us the direction of the graph. So if we see a graph where one is increasing and the other is decreasing, we know that's a negative correlation. We know that it's going to be a negative number. If we see a graph where one is increasing and the other is also increasing, we know that number is going to be positive. The closer the number is to a whole number, between -1 and +1, the stronger the relationship becomes. So a perfect positive correlation is going to be +1. And that means that as one factor increases, the other increases at the exact same rate. A -1 correlation tells us that as one increases, the other decreases at the exact same rate. The closer we get to 0, the weaker the correlation becomes. So if we see a correlation of negative 0.2 or positive 0.3, we know that those are negative or positive in the direction that the graph is going, but that both of those graphs are very weak correlations, meaning there's almost no relationship between the two factors that we're looking at. So that is how we're going to read these correlation coefficients. R tells us the relationship, positive or negative tells us the direction of the graph, and the number tells us how strong the correlation coefficient is. As we said before, and as we'll say 100 times, correlation does not prove cause and effect. Because if it did, we would see some pretty concerning statistics when it comes to correlations. For example, we have seen that as ice cream sales increase, so do the rates of murder in the United States. And that's a real correlation. And that's a little concerning. Does ice cream turn people into serial killers? Of course not. But we do see a real positive correlation taking place between those two statistics. And the question is, why? Why is that happening? Now you might be able to figure out what the third variable is here that both of these statistics have in common, and that of course is warm weather. In the summertime, we see higher ice cream sales, and we also see higher rates of violence. And that could be because of a variety of factors. It's light out for longer, people are outside more often, and so they're more likely to come into contact with others where violence might occur. In the winter, when it's colder and darker, we don't leave our houses as much, we have less of a chance of running into someone we don't get along with. But this ice cream and murder example shows us that sometimes we see what's known as illusory correlations. Correlations that look real, but they actually have no relationship between the two. One of my other personal favorites, and this is a real correlation as well, is the highway fatality rate and the fresh lemons imported to the United States from Mexico. Here we see a strong negative correlation of negative 0.97. That seems like a pretty strong correlational relationship here. But again, the more lemons we consume does not make us safer drivers. But this is the risk that we run when we look at correlations and we turn them into cause-effect relationships. Newspapers love doing this. They love taking correlational studies and they love implying cause and effect in their headlines to grab people's attention. So we always need to be cautious when we hear about relationships or correlational studies. If we want to know if that's actually true, if we want to prove that lemons make us safer drivers, for example, we need to create an experiment where we can give people lemons and test their driving ability. Only when we can control the different variables and actually prove cause and effect would we be able to come up with a conclusion of that study to say definitively whether or not that is actually happening. So in our next video, we will go ahead and talk about experiments. But hopefully this gives you an understanding of what correlations do and what they are, and how we will be expected to read those graphs and report on what the relationships are that we see. Thanks for watching, and remember, be kind to your mind.